Hello and welcome to our lesson on understanding the vertex form of the quadratic equation. Today we're basing our work in the standards from Common Core and NCTM that state that students will be able to graph functions expressed symbolically and show key features of the graph by hand in simple cases and using technology for more complicated cases. Students will be able to create equations in two or more variables to represent relationships between quantities, graph equations on coordinate axes with labels and scales. In grades 9 through 12, each and every student should understand relations and functions and select, convert flexibly among, and use various representations for them. The goals and objectives for this lesson will be that students will be able to switch between standard and vertex form for the quadratic equations. Students will know that standard form and vertex form are equivalent and make the same graph. And students will be able to understand the shifts in quadratic equations in the written vertex form equation, and will understand how this relates to shifts in the graph. The academic language necessary for success in this lesson include quadratic equation, which is an equation in which one term has a variable raised to the second degree. Standard form, which is for quadratic equations. Standard form looks like this: f of x equals ax squared plus bx plus c, where a, b, and c are constants. Vertex form is where g of x equals a times quantity x minus h squared plus k, where a, h, and k are constants, and hk is the vertex of the parabola. A shift is where a transformation of the graph has been made vertically or horizontally. The vertex is the highest or lowest point of the parabola, and the parabola is the U-shaped graph formed by the quadratic equations. Now that we've gathered that information out of the way, let's begin the lesson. So we are now comfortable with switching between standard form and vertex form, but are we really sure yet that they are in fact the same equation? How do we know that we didn't just do some algebraic magic and poof, two things that don't look at all similar suddenly come out to have the same graph? Now we're going to make sure that we truly understand that they are the same. So we're going to go into graph, plot new function, and we're going to put, just for now, we're going to write in x squared in graph. All right, and now we're going to place a point on that graph, and we're going to animate the point. We're not going to do anything with it quite yet, but let's set the speed f5. All right, and this point will stay on this parabola. That'll be important for later. So let's graph another one, and we're actually going to do the same equation, x squared. Now we all agree that h of x and q of x are the same graph because x squared looks the same as x squared, and their parabolas are right on top of each other. So we know that these must be the same. But what happens when we make one equation, x squared plus 6x plus 13, and we change this one to the vertex form of that standard form equation? So work with your partner, figure out what the vertex form is going to be of this. All right, get your vertex, put in your parentheses. Once you think you have it, so it's the right one, press OK. All right, so it seems to have moved to the same part. Now, if you were to look at these graphs, would you say that they're the same? I mean, they look pretty close, right? But how do we know for sure? You know, mathematics has to do a lot with rigor. How do we know for sure that they're absolutely the same? So take our point that we animated earlier, bring it over here, and we're going to follow that point and watch as it goes all the way around the parabola. It's tracing this one, it's tracing h of x, and if it traces the whole thing, then we know that h of x and q of x must be the same. So let's watch. Well, that looks pretty good to me. Try another one, come up with a standard form or vertex form equation on your own, and then you and your partner will go through each of your equations, switch them to the other form, whether it's standard form or vertex form, whichever one your equation is not in, and convince yourselves that that is in fact the same equation. Great, since talking is dying down, you guys seem like you are well and surely convinced that standard form and vertex form, while they look incredibly different, are in fact the same. So everyone open up your Geometers sketchpad to the 4th page. We're going to skip the 3rd page for now. Great, so as you can see here, we have the generic form of the vertex form of the quadratic equation, right? And so now we're really going to look in depth as to what each part of this equation does and how it affects the graph. All right, so here's how this is going to work. Obviously, we're going to be looking at the A, the H value, and the K value. And we're going to be investigating how these shifts affect the graph. So I have on your 3rd page a graph of a parabola. Just double click on the parabola and you can alter this however you want. Maybe you want to add a 5 in the front. Maybe you want it to say -10, and then maybe you want to say, oh, let's mix it up. Let's go -6. We want to see how this graph looks. All right, so it jumped all the way over here. So what I want you to do is with your partner, you're going to be taking this equation and altering it. Alter what's in front of it, alter this value right here, and then alter what's behind it. All right? And as you go through, try and find patterns and look to see all the different shifts. Okay, well that made it jump over here, but what happens if we change this value? How does it change? And make sure you're looking for those patterns. And as you're going through that, the 3 values, as I said earlier, that you're going to be looking for again are this A value, how does this affect the equation? This H value, how does this affect the equation? And this K value, how does this affect the equation? Once you feel like you have a good understanding of how one of these 3 affects the equation, I want you to go to that letter, let's say A, and you're going to click on that button. There are going to be 3 paragraphs, don't worry, they're really short, that come up, and I want you to focus on the first 2 with your partner. And once you feel like you have grasped those 2, then you can move on to another letter, say H. And again, with your partner, plug and chug in the graph, figure out by changing this, how does it change the graph? What patterns can I see? And once you think you have a pretty clear understanding of how H affects the graph, go ahead and press the button. And then you'll have, again, 3 paragraphs, focus on the first 2. And once you have that done, move on to K and go through that. And once you think you have a good understanding of those, press K, and you'll be able to go through those 2 paragraphs with your partner. There will be the 3rd paragraph on each of them. The bottom one, it's just one question. Leave those till the end, until after you've done the first 2 paragraphs of A, H, and K, because those are a little bit more challenging, and I don't want you to waste your entire class period trying to figure those out. All right, I turn you loose. Make sure you're trying to really pull out patterns, figure out how it's being different, how the graph is shifting, why that number made the graph shift over here versus over there like it did last time. Make sure you're engaging in dialogue with your partner, and I'll be walking around. All right, everyone, I'm hearing really great conversation. It seems like a lot of people were able to figure out the H and the K value really well, which was awesome. You guys were saying a lot of good things, talking about how the H and the K come from the vertex, which we already knew, so good job there, guys. And you're talking about how, well, since the H is the X part of the vertex, we see how that's been shifting in the horizontal direction, left and right. And how the K, well, that's the Y part, that's the Y coordinate of the vertex, and how that's doing a lot of the vertical and horizontal shifts. That was really great conversation, guys. I also liked a couple people were saying, why does the H have to be negative here? And we're going to talk about that later. So remember, that's going to be honing in on that 3rd question, which we will get to. The A was a little bit more confusing. I think that maybe you guys were having a hard time coming up with values to put in. Like, for example, I noticed not a lot of people were putting in 0.5 in front of it, and we see it's going to widen it. So we saw a lot of people noticing that's going to shrink, but we didn't really get a lot of the widening. So that was really good discussion. But remember, when we're dealing with numbers and we're inputting numbers, this can be anything. Positive, negative, big, small. We can even put in 0.000005 and see what happens. All right, and it almost disappears because it's so small. All right, so just keep that in mind as we're going through these exploration activities, that any number is fair game. And it's good to test all those different random ones because we can get some pretty interesting results based on those. All right, so make sure that you have those copied down in your notes. Make sure that you have those and that you're understanding them because we're going to be working with those a lot. Good job, class. For your homework, just continue to think about these bottom 3 questions, all right? Maybe play around some more with the graph. Maybe play around with some algebra. Switch between standard form and vertex form a couple times, even if it's just in with the variables. All right, just make sure you're comfortable switching from standard form to vertex form, and make sure you're really comfortable with knowing exactly what these 3 values do for the equation. Great, I look forward to seeing y'all tomorrow. Bye.